Okay, one thing I would add to what we did the first time is when you guys make your table of values, I would always start at 0, 1, 2, 3, because you need the 0 term, okay? And this is just x and y, right? We don't know what 0 is yet. We're gonna try and fill in this box, okay, in a minute. Okay. But what we do know is we can look at the picture. In the first one, we see, in stage 1, we see five boxes. In the second one, I'm going to see 4, 8, 12, 16, 20 boxes. And then the third one, 9, 18, 27. How many is that? 9 and 5 should be what? 50? 45. Yeah, you're right. 45. Okay. Then you're going to run through what we called first differences. And we should see that these shouldn't match. That's okay, right? So we're just going to go first differences are the differences between the y values. So 45 minus 20 is going to be 25. And the difference between 20 and 5 is going to be 15. Okay, so they don't match. That's good. So then we move on to what we call the second differences. Okay? And you guys, there will be a question to lead the exam off that is a visual pattern. I will say it might be worth 10 marks or something. I don't know. 5 marks, something. Come up with the equation. Yeah, Paul. I have to pull it together still. It's probably not a normal exam for the purposes of like I have to have your marks in by Monday.
It's gonna be like shorter, you mean, or?
Yeah, it'll be on the shorter side just from a marking perspective probably, right?
How many multiple choice are there?
I don't know. I have not written it. I have not pulled it together yet. I have questions done. Like there's questions all over the place. I haven't compiled it yet because I haven't decided like what we get through in review, what did we not get through in the class, which wasn't much, but how well do you guys work is also gonna like, you know, what do you show me you know now relative to what I have to ask you because you didn't show it, right? Is kind of the idea, right? But for sure, there's a visual pattern question right at the top. First question you're gonna see is gonna be a visual pattern. I'm just gonna make that a thing. Okay, it's gonna say come up with the equation. Here's the pattern. Okay, so what's the difference between there? The second difference. 10, right? So at this stage, you can do one of two things at this stage. You can just decide to, once you have the second difference, you know what your A value is going to be. We said, and remember, when I say A value, we're trying to write this equation like this. Trying to write it in standard form, right? So when I say we found the A value, basically the A value is going to be equal to the second difference is 10 divided by 2. It's equal to 5, okay? So that's part 1. You now know one piece of the equation. You know your equation is going to look something like y equals 5x squared. Okay, that's where that goes. And you're just trying to unlock all of the pieces. Now the next piece that we're trying to figure out, what you can do from the table, and why we promote the table. If I were to work backwards from the second difference, right? I've told you this is a quadratic relation, so you're believing the fact that this is all going to be 10. All the second differences are going to be 10. So I can write it again here. What that must mean is that the difference between 15 and this next number should be 10. So I'm basically going to go 15 minus 10 to get to here is 5. Okay. We're almost there. Right? Again, if you look at the pattern of what's gone on here, I'll pull up a highlighter. Highlighter's right better. If I look at this number, I went from 20 minus 15 gave me 5. So I'm going to do the same thing here. I'm going to go 5 minus 5 should be what? 0. Okay. In doing that, you have now found the C value. Okay. This value right here is C. It's what happens. It's your, okay, I'm going to reword this. It's your y-intercept. That should mean something to you based on what we did this morning already with the matching exercise. It's your y-intercept. Where did we get the y-intercept from in our equation? Tobias. Is that, were you answering the question? Oh, okay. It's always the C value. That's the y-intercept, right? I know that the C value in this question is 0. So now you get to like kind of erase C. It's going to be 0. Right? Sometimes you can visually see what the equation is right off the get-go. I'm probably going to pick one that you can't. Right? Because Red has already told us what the answer was for this one. Okay. I think he was kind of able to do that because we kind of recognized that the C value was 0. But again, like when we started this together, like, because I told you I was learning this as the day we kind of did this, I had kind of unlocked this pattern, right? So the more of these that I've started to do, I can start to actually like visualize what's gone on relative to the equation because I know what's what. So I understand how Retta is actually like visually looking at that, and it's just apparent. Yeah.
The other thing is like, as you can tell that like the little parts in the middle is like x squared, but then you see it's the same thing all around it.
Oh, sorry. You are talking about the equation or the picture.
Yeah, I'm talking about the picture, right?
Yeah.
The other thing that really helps, like visually, is just like if you look around the center, let's say for step 2, it's 4, right?
Yeah.
And around it, it's 4, 4, 4, 4. So that kind of just gives it away.
Yeah. That's what I meant. Like, it looked like a harder question, but it's not necessarily a harder question. It's much like number 2. Okay. Okay. So we've unlocked 2 pieces. In order to actually answer this question, or like to provide me with the equation that's always going to work, you're going to have to tell me all 3 pieces, A, B, C. Okay. You now know A is 5, C is equal to 0. You can solve for B. Right? The nice thing about this process is it's the same every single time. You don't have to look at the picture. You just count the number of boxes, apply this process, you're going to come up with the equation every time. That's why I'm confident now that like it doesn't matter what I put up on the board with you guys or what question you ask me to do. I'm going to apply the exact same process and I'm going to come up with an answer. Right? So, all I have to do is solve for B. And I have my equation that works. Right? Well, I also have some things over here in my table, like a point. I have an X and Y. I'm going to pick 1 and 5. Okay? So, this is what I'm trying to do now. I'm trying to solve for B. Okay, so I'm going to rewrite my equation here. Y equals 5x squared plus bx. I don't really necessarily care about the C term because it's 0. So it's just like I'm not going to write it, right? Because it's just plus 0. So I don't need that there. If it was a number, then it would matter. If it was like plus 7, you'd have to write it down. Okay? But now I can just plug in the point that I have, the xy. I can plug that into my equation and solve for b. 5 is equal to 5 times 1 plus b times 1. You get 5 equals 5 plus b. What happened? Should we get 0 equals b? So sometimes the visual pattern can actually like, it's interesting. Okay, remember what I did here? I was just counting boxes. Sometimes we can take a question, like a visual representation of a question, and we can change it based on what it is I'm actually asking you for. So for instance, if we took this question and I asked you, like, let's say we built each of these pictures out of toothpicks, that would be a much different question in terms of an equation than just the number of boxes. Because now, if you look at the first picture, you're getting 4 toothpicks for every picture. So the equation should look different. Okay? So I guess this is kind of like, there's an equation that works if you're counting the number of boxes. And then it's kind of a 2-step thing, like in stage 4, like you now know if I plugged in for stage 4, if I plugged in x equals 4, because that's all I'm going to do, I should expect to see 5 times 4 squared, which is equal to 5 times 16. 32, 64, and another 16 should be what, 80? Okay, so I should expect to see 80 boxes. How they're oriented might be a different question, right? You might have to strategically look at the pictures and draw them in a way that fits the pattern, but you know there has to be 80 boxes. Okay, does that make sense? If you apply this process, that equation can tell you how many boxes would be in whatever amount of stages, right? And we kind of remember on the day that we did these, we kind of showed you the Excel file where we were like, how many boxes are in the 100th picture, and then like, or sorry, how many toothpicks would be in the 100th picture, and how many toothpicks would I need to build all 100 pictures? We were able to answer that with Excel, right? So we built the equation. That's what this does. Does that make sense? We can do more over the course of the day today. It doesn't matter to me. Okay? We're gonna do that whole sheet. Doesn't matter.